we can talk about the area of certain types of triangles, the area of an isosceles triangle, for instance. This is kind of a weird looking formula. The thing to note when we're dealing with a formula like this is that you do need to pay attention to what A and B mean. I have an example of an isosceles triangle here. You can see A is the side that's repeated. So two sides have the side length A, and the other side is side length B. If we were to plug those things into this formula, we could get the area of that particular triangle. You could actually get to this using some Pythagorean theorem, figure out what the height is, and get to it that way. But this gives you a nice kind of enclosed formula that doesn't take a whole lot of work to get the area now. So we get 1/2 times base. The base here, well, okay, I'm calling it a base, but it's really B. It actually does kind of function as a base in this one, though. So if you're having trouble remembering, you could think of the B as the base here. So in any case, we get 1/2 times 12 times the square root of 7 squared minus 12 over 2, so 6 squared. I get 1/2 times 12, which is 6, times the square root of 49 minus 36. 49 minus 36 gives us 13. So we have this number times the square root of 13. Let's type this in there. 6 times the square root of 13 gives us 21.63, whatever. Now this one, if we were to use Heron's formula on this one, and let me just remind you what Heron's formula is. We use the semi-perimeter, which is the sum of all the sides, but divided by 2. So perimeter divided by 2, which in this case is going to give us 7 plus 7 plus 12 divided by 2, which is 13. And the actual formula here would be the square root of 13 times 13 minus 7 times 13 minus 7 times 13 minus 12. So this is probably a better example of Heron's formula than the one I did in the previous video. 13 times 6 times 6 times 1 gives us 468. We're taking the square root of 468, which gives us 21.633. So you can see this one we do actually get the exact same answer for both of these because there was no rounding involved at any of the points. On the previous example in the last video, I think the side lengths were rounded off or something. So there was some funny business going on in that last one. But on this one, you can see Heron's formula gives us the exact same area.